Good morning, good evening, good afternoon, wherever you're joining from. My name is Hjalmar Gislason. I'm the founder and CEO here at GRID. So happy to have you on this hands-on demo that we are going to run of our spreadsheet API solution and the AI capabilities that are associated with it. Some of you joined our webinar or our conversation last week with Donald Farmer, where we talked about the calculation problem. Essentially the fact that LLMs cannot properly be trusted with even simple calculations. For those that didn't, I will repeat that message very quickly, and then we'll dive into our solution, what it's all about, and how you can make use of it. So without further ado, let's dive in. A couple of housekeeping things first, though. I will be doing 25 minutes or so of an introduction and a demo of our solution. Feel free at any time to put questions into the Q&A, and my colleagues will be keeping an eye out for these ones. You can use the chat to talk to each other, and for everything else, everything other than questions you'd like addressed in the session. I may pick some questions up along the way, but we leave some room at the end for Q&A. So, we can run that for about maybe 10 minutes after we're done with the demonstration. So I think that's that. Not terribly unusual or complicated. So let's just dive in. The context that I mentioned before is this calculation problem. Essentially, a lot of people are working with LLMs or on LLM-based solutions these days, AI-based solutions. And one of the things that they may know or may not know yet is that calculations, working with numbers, even simple calculations, can be problematic for LLMs. They will be very confident in their answers, as they often are, but they can also be wildly wrong at the same time. So in order to deal with that, we need tools. One of the tools that many people use for their numbers and calculations are spreadsheets. A lot of people know how to use spreadsheets. And what we are doing is we are bridging these two worlds, the world of AI and LLMs on the one hand, and the world of spreadsheets and spreadsheet calculations on the other. A little bit here. So LLMs can't calculate. This is kind of a central theme here. But I have two screenshots or two snippets here that I want to point out. On the one hand is, on the left-hand side, you will see what is a slightly annotated graph from a science paper where they're essentially comparing the best LLMs at math. This is from 2024, so things may have improved, but what it's essentially saying is that the best performing purpose-trained LLMs get about 85% of 5-digit calculations right. Again, this may have improved. That said, we have had pocket calculators for over 50 years, probably for over 60 or 70 years, that can do this 100% right, can do this right 100% of the time. So essentially, trusting an LLM or outsourcing a calculation to LLM is for many purposes, so for many reasons, not the right tool for the task, where we have perfect tools. We have very good calculators. We have very good calculation algorithms that can do math 100% right. The other snippet here is from a paper called Hallucination is Inevitable. What that is about is essentially, it essentially says this is not a problem that will go away. Now, again, LLMs like reasoning models and so on have become better at this, but LLMs unassisted will at no point be flawless when it comes to calculations. In fact, their creative solutions and their creative use and their kind of fluent use of language may very well be the result of them being statistical models and and not deterministic models that get things like math 100% right 100% of the time. Spreadsheets, however, are very good with numbers. There are over 1 billion users of spreadsheets in the world. In many ways, spreadsheets are the original low-code solution. They are where a lot of us business users turn to when we need to do data analysis or simple calculations, and they are where most business calculations live. Not being able to tap into this valuable resource is going to be an hindrance to any LLM project that is supposed to make us more productive and more effective at our everyday tasks if a lot of our everyday tasks are happening in spreadsheets. So in one way, or in some way, you can think of our solution as a way to make workflows or processes that rely on spreadsheets and spreadsheet calculations available to AI and automation. So automation also being a part of that of that equation. So we are bringing these two worlds together. Like I will talk more about kind of the automation part as well, but on the AI side, we're bringing these two worlds together. Being able to answer questions such as, what would the gross margin be if we raised the price to $79 a month next year? Give me sensitivity analysis for net revenue based on churn and ad spend. For every new lead, get the company size, revenue, and growth rate, and calculate a lead score, even kind of storing that back to a CRM or a database based on a calculation that happens in a spreadsheet. Help me estimate the staffing cost for this new location, assuming this is a continuation of a conversation you're already having with an LLM planning out, something like a new location for your business and so on. These are all types of questions that we are used to answer using spreadsheets. Now, the spreadsheet models need to exist for an LLM to be able to answer these questions. We can have a separate conversation about how LLMs can and will in the future also help building models. But what we're doing here is we're making existing spreadsheet data and models accessible to AI and automation. This is not about how you build spreadsheet models using AI. All right. Well, that was the problem. Here we kind of move into the solution space. So one way that LLMs can not only do math, but also a lot of other things is by writing code. So if you asked a math question and you didn't have a spreadsheet model or you were not a spreadsheet user, you could still ask an LLM a question that required calculation, and as long as the LLM writes code and then runs that code to get the answer, that is something that at least you can trust that the calculation is correct. The assumptions may not be correct, but the calculation is going to be correct, and it's going to be deterministic. That is done by the LLM, which is a language model at the core. They can, as we've seen, they can deal very well with English and other languages. And the programming languages are just another type of languages. So they're very good at writing code that you can then run to do calculations. But if you have a spreadsheet model, if you have already done the work of modeling out your business or running through the exercise of making your financial forecast or something like that in a spreadsheet, then any code won't be able to work with that. You actually need a spreadsheet engine, something like what's inside of Excel or Google Sheets that looks at the formulas, looks at the way different formulas are connected through references to values or other formulas, and can run the entire calculation of the spreadsheet and thereby give an answer. And the way to connect that to an LLM is via an API using what is called tool calls, tool use, function calling. These are all different ways, different platforms and different technologies refer to the capability of an LLM to call out to an API for a response. An API might also have things like weather data or some other facts and figures. But in this case, we're using an API to connect to a spreadsheet engine. So what does a spreadsheet engine do? A spreadsheet engine essentially turns a spreadsheet with, here we have a very simple one with a two-dimensional layout, turns that into a dependency graph that essentially allows it to run the calculations correctly and effectively. So here, this picture essentially shows how this simple spreadsheet has been turned into a dependency graph where cell B2 and C2 feed into D2. So you can see that here. That makes sense. You're going to multiply the number of seats with the unit price to get the total for that line item. Then D2, D3, and D4, these intermediate results here, feed into this cell here. But in this model, we also have a minimum price. So the price is never going to go below 1200. So D6 and D7 feed into D9, which is the result here. Now, there may not always be a single result, and even the result that's at the end of such a graph, or in this case, a tree, it isn't necessarily the most important number. Let's say that you had financial forecast, you might be even more interested in the month by month bottom line than in the bottom line for the year, even though the bottom line for the year is a sum of the bottom line for the months and so on. So this is one part. Now, at GRID, we have been building our own spreadsheet engine. We're not shy to say that it's the most sophisticated spreadsheet engine that exists outside of Microsoft and Google. The main difference from these engines is that it's not tightly coupled with a UI. It's not linked directly to something like the Microsoft Excel client or the Google spreadsheet or Google Sheets interface in the browser. It can run the calculations independently of then whichever interface you run on top of it, whether that's a UI that you run on top of it, or simply an API that can run the calculations independent of whatever UI you may be building as a programmer or any other user of the API. Been developing this spreadsheet engine for over 6 years. It's deeply compatible with both Excel and Google Sheets, even where they diverge, even where they don't do the exact same things. The other thing we do is that we will do language enrichment. This is very important for the AI side of things. We'll do language enrichment of the spreadsheet data. So what that means is that if I look at cell C3 in this spreadsheet here, it simply has the number 500. But I, as a human, can easily see that this is the unit price for sites. It's simply by kind of eyeballing the labels, the things that are labeling this cell. The Excel file, in this case, does not have that information on this cell. So when you simply read the file, you will just see cell C3 has the value of 500 and there's no metadata, no language or labeling data associated with that. What we do is that we will look for these types of labels and we will save them as metadata on the cells. And this allows the LLM to say, when you say something like, what is the price for, let's say 99 users across 9 sites or something like that. So you say users instead of seats, it will still be able to associate that with, seats and users. LLMs are really good at this type of ambiguity. You can fill in the number 99 here, 9 here, and give us the calculated result from cell D9 in this case, which is the final price. So that is how we make a spreadsheet model with its deterministic calculations available to using natural language. So let's, and then final thought here. The way this works is that our engine will read an Excel file or a Google Sheet and turn that into, kind of internalize that, turn that into a scalable, secure web service that can be called thousands of times a second if you want. It runs these calculations, and that can in turn be used by traditional software. If you're making a traditional software project that is independent of AI, you can use that to leverage the calculations that have already been encoded in your spreadsheet and use them. Let's say that you wanted to do price calculations, or you wanted to do quoting, or you wanted to do sensitivity analysis in your own software or in your own project, you can do that. Then there are LLM projects where you might, for example, be ingesting your own spreadsheet files via programmatic interface and then use the language enrichment to make internal documents, for example, available for querying with natural language, so that you can ask questions like, our churn rate has increased. What does that mean for the bottom line according to our financial forecast or something like that? And then finally, you can connect that to LLM environments, more like end user environments that have tool calling or other API features associated with them. Something like building out a custom GPT, which is something that we are intimately familiar with, or an MCP for Claude. You can use that to call to the API to then build out, as a business user, as a no-code user, build out your own solution that makes use of the language enrichment to in turn make the calculation in your spreadsheet available to via natural language. So let's peel the onion here a little bit. So I'm going to first show you a spreadsheet. So this is the same spreadsheet as we were looking at before. It has slightly different values in it. The reason I use such a simple model is that it's very easy to kind of talk through it, but I'll then show you a more complex one, and you can then go in and experiment with this and prove me right on what I'm gonna say when I tell you that it can handle even the most complex models. Again, over these 6 years, we have dealt with tens of thousands, probably more than 100,000 different spreadsheet models, and run even the most complex calculations at scale. So, we're talking through this simple one here. It's a pricing model. We've seen it before. There's a number of seats and sites that determine the price in addition to whether or not you are signing up for the priority support. There is a minimum price of 1,200 as well, and the final price is here. What happens if I log into the API environment? So here, I have a bunch of spreadsheets in here. When you log in for the first time, and you can sign up for that on our website, GRID.is, if you sign up for that, you will have an environment. You'll essentially just have a big green button that says Add Spreadsheet. When you hit that, you can add a spreadsheet either from a cloud drive, something like a Google Drive, a Dropbox, OneDrive, and so on, or you can upload a file from your local computer. I'm going to upload the file that we were just looking at, so that's going to come from here, and that is the simple pricing one, I believe. Moving my Zoom controls, yes, that is the simple pricing one. So when I do so, you will immediately see the spreadsheet in our environment here, and you are now in the API environment to run queries on top of this spreadsheet. The system will automatically come up with a suggested query just so that you can start experimenting with this. So here it's suggesting that we apply the value 60 to cell B2, which is this cell up here that's highlighted, and then that we read the values from D9, which is here, D6, which is here, and then D2 and D3. This is the automatic suggestion. Actually, in this case, I am only interested in the results from cell D9. So I'm going to remove these other things from the query. This is the full formed query now. And when I hit try it, which runs the query, it will repeat what was done. We applied the value 60, and then it read the following values. So it read from cell sheet 1 D9 up here, it read the value 9,940. And similarly, if we write a different value, let's say we want 160 seats, it will rerun that calculation and give us the result back in the API response. Now we can verify this. So 160 and 4, we go back to Excel, 160 and 4, 14,840. That's indeed the result we got here. Now, this is what we do here in what we call the sandbox, which is immediately in your face after you have uploaded a spreadsheet, is the query endpoint, which is the most used and probably the most useful endpoint that allows you to query individual spreadsheets. But there are many other calls in the API. So if we go to the documentation, you can actually access all of that over here. All of the API resources are available in this one screen. If I go to the API documentation, it will take us here, actually in this case, to the documentation for the query endpoint. Here you have detailed instructions about all the different properties of that call, and you can even try it out. So we've already tried out the query one. Yeah, there is also an endpoint for uploading a workbook. And you have code examples. So if you're writing in JavaScript or Python or Java or Go or whatever you are using, you can get these code examples right away. For any of these calls, you can list the workbooks. So we can try this one just because we haven't, well, we tried the query one in the sandbox, but we can try this one as well. In the documentation, you can just hit try it. The bearer, the authorization key, the bearer which is sent over bearer, is the API key from here. So you can copy that from here and paste it in. The reason it was already filled in my environment is that I've already been using it in this session, but you know, I would essentially go here. This is what it would look like when you come here first. You paste in that API key, and then the list workbooks or the workbooks endpoint just takes one, or it takes two parameters. One is how many we want to list, and second one is where we want to enter the list. So 20, we could do 25 at a time, and then we could do the next 25 by starting this at 26 and so on. So if I want to list, 10 of my workbooks, I can do that. I can send that over the wire, and here inside of the documentation environment, I get a list of my workbooks, and we see here at the top, this is by default sorted by in reverse order, in kind of in time order. So the latest one will be at the top here. Similarly, there is an endpoint to export an Excel file, even with the changes that you made. So if you apply different changes to the workbook, you will be able to download the workbook. This can be really good for templating, for example. You might put into a spreadsheet model, you might have calculations there, you might want to fill in data, even hundreds of rows of data, applying them and then exporting the file as an Excel file, and you can render a chart. This is probably more so than in an automation. This is more relevant in an AI environment, where you might want to chart the results, even the results of a query that has changed the assumptions in the model. Now let's move over. So this is all, this is the API. The API is the key to everything we do in here. But so this alone makes your spreadsheet models available for automation and working with it in any regular software project. But let's take a little bit deeper look at the AI side of things. So the first thing I'll show you here is I'll go into, so this is something that you will not have in your environment. It's a page that's only available to people internally at GRID. But this allows us to click any cell here and see which labels we have detected. So you'll see here how priority support and unit price are the labels for this one. How total and sites is the label for this one. How total and final price is the label for this one, and so on. Very much like we would kind of eyeball these things ourselves. And if we go into a slightly more complicated spreadsheet, I'll show you it briefly in Excel first. So be something like this. This is actually more like a financial model or a file that you might find on your internal drive. In here, it's a revenue model for an imaginary subscription business where you have an ad budget and you have some cost associated with that. You have different conversion ratios and churn rates and price and so on. And then we are using that to calculate monthly numbers down here. Now, I'm going to show you again, like here. I've already uploaded this one. If I go into the labels debug for this one, You can see how lag from visit registration is the label for this one. Churn rate is here. If I go down to here, we will see that both March 25 and monthly recurring revenue are labels that lend meaning to this particular cell, and so on. And then down here we have kind of the ARR in month 36. So that's actually the only label for that one. Now, how does this work in the AI? In the AI context? If we move over here to the chat demo, we can actually have a conversation with this spreadsheet. We can say something like, let's just start with something easy. We're just going to ask for, the ARR. So what's the annual recurring, just to make it a little bit more challenging, and again, kind of playing on the strengths of LLMs here. You can see that this cell highlighted as soon as we got the query, and then we're using OpenAI. In this case, behind the scenes, we have actually run this on top of many different models, including Llama. We've used Perplexity's API. We've run this on top of Claude as well, and we get back the answer. So that was simply reading a value from here without changing anything. Now let's do something where we actually run some calculations. Let's do what is the but what is it if what do we have here? Maybe the churn rate. If we get the churn down to 5%. So what happens then is you will probably see this cell highlight here and the value 5% put in here, which caused a recalculation. And down here we see the value. So if we reduce the churn rate to 5%, the annual recurring revenue would be 579 or $580,000 or so. So you can, with this, you can essentially ask, about different values. You can ask for values for different months in here and run any calculations in here. And what we have done essentially for you are two things. We have turned the spreadsheet model into a web service that you can call from your own software. And we have layered a language layer on top of it that allows you to turn natural language queries where you are referring to things in a spreadsheet model in natural language, triggering calculations and reading results from there. From even this is not the most complex model, but you could do that from even your most complex models, and it would run the calculations exactly like you would in an LLM. And teach you one quick trick here. I don't know how well this is documented in here, but you can ask for an explanation. So well, I made a typo there, but it essentially tells us that, where it wrote the value, what it read from there. So you can ask it to kind of show its work. In some clients, we've built on top of this. So again, this is just the API environment, but in some clients, we've actually made those explanations available on click. So if you think of an application you are building, you can have the explanation available next to the results so that people can learn to verify, but then over time learn to trust the calculations that come back. So I know this was very fast, and we kind of went over what we went through here is what it is we're building, which is a way to turn spreadsheet data and spreadsheet models into API endpoints that you can call via a RESTful API. I spent some time showing you the endpoints in the API, and there are more endpoints coming that will give you additional details in here. Then we talked about the language detection, how we are assigning labels to different things in here, making them available via natural language. And then finally, how you can tie it all together in an LLM project that has the ability to call out to an API where it translates queries that you write in natural language into API queries and then incorporates those results in a response that comes back. So I will leave it at that, and we will move to the Q&A. So I see there's quite a lot been going on in the chat. I'll start with the Q&A here. Right. So There's a question here about how complex can the underlying spreadsheet be? For example, can it be a detailed financial earnings model? The answer is yes. So the spreadsheet engine, again, has run even the most complex, really big, really complex models, and is fully compatible with what you would see in those models running in Excel or Google Sheets. There is a caveat here. Some of the LLM models have a fairly small context window, which is essentially how much data the LLM can work with at the time. So you may actually, you may run it with a very big spreadsheet. You may run into these limitations. There may simply be more language information in the spreadsheet than the context window of the LLM you're working with allows for. But we have ways of prioritizing these as well so that we are sending over the ones that are most likely to be used, and you can even customize them. So if you are making this available to, if you are making a single spreadsheet available to a large audience, you may already anticipate or even want to dictate how it may and can be used. So you can lock down cells that people are not, that people shouldn't be able to read, or the cells that they should be able to read or even kind of apply different values to. So you can control that. But the spreadsheet engine, the calculation engine itself has very little limitations. You can run even the most complex models there. But in the interplay between the LLM, because of the context window, there may be some limitations. We have another question here, which is, does it also work that there are circular references in the spreadsheet? Yes, the spreadsheet engine, our spreadsheet engine can run circular references. We can do iterative calculations if they are set up in the spreadsheet, and we can do goal seek, for example. Didn't show you there, but we could have asked something like, what would the ad budget need to be if we wanted to reach $1 million in ARR based on that model? So circular references, absolutely. So then there's a question here. Can you start with an empty spreadsheet? For example, in a conversation with an LLM, can I describe a model and have the API create the spreadsheet data on the platform? So I mentioned in the beginning, what we are focused on here is making spreadsheet data and models that already exists available. We have run some experimentations on building models from scratch, and we believe that's the next frontier to work on. So that is not currently available. However, what you can do is you can start with a template. You can start with a spreadsheet that may have some of the data and the calculations in place, and you can fill in the data and it will run the calculation. An example of that would be, let's say you're doing financial analysis. You always use the same spreadsheet to run your financial analysis model on, but you could have the LLM fill in all the data for that model, even from like extracting that from a PDF or kind of using some other cool LLM features to then put that into the model, and then have it export an Excel file that has your template filled in with the data for that particular company. So the short answer to the question, can we start with an empty spreadsheet, is you can start with an empty template and fill it in, but so what's up next is working on capabilities to help users build spreadsheet models from scratch, not just write individual formulas, but entire models. Then we have a question here. How could we share the chat feature with colleagues so we could both query the same model with an LLM? Great question. So there are many ways you could do that. This is more a question about the LLM environment, but a good way to do it might, for example, be to use a custom GPT in ChatGPT, or a project in Claude, as long as that project has access to an MCP server that can answer those questions. And then you can use the features of ChatGPT or Claude to share your project or share your custom GPT. So in short, you could put up your model. You can then build the custom GPT on top of it. It might be, let's say it's a pricing or quoting. A good example would be a quoting ChatGPT. You might fill in some of your product sheets and so on so that it can also talk about kind of the textual parts of it. But then you wanted to run the quotes through the calculations. You could build that custom GPT out on your own, make it do a tool call out to the spreadsheet model once it's been uploaded into the API. And then you can share your custom GPT with your colleagues so that they can all have a conversation with the same model. Another question is, how reliable is the labeling? If the Excel workbook has named ranges, will they be used for labeling? So the labeling is something that is, so I'll start by saying it's very good, but there are also, we've learned that there are a lot of different ways people structure their spreadsheets, labeling them in such a way that usually humans will not have too much trouble reading it, but computers, even LLMs, may sometimes have issues figuring them out. There are often visual cues. You may have colored or formatted the text, and that indicates that everything below it is a hierarchy and so on. So we're continuously working on improving that. But on the second part of the question, which is the named ranges. So named ranges, if you have named the cell, then that is absolutely used for labeling. There is also a feature, a UI feature within the LLM, within the API environment that you had, where you can add labels, you can add additional information. So if you want to give more information about a cell to the LLM than is already in the spreadsheet, you can edit that in the API environment to add to it. Is there? Yes. So there's a question, is there a way to use API to query spreadsheet using LLM, for example, /query? Yeah, right. So I think what this means is that, is there a way to build the query almost like using a syntax in the instead of using natural language? You can absolutely build out your own agent that can do that as long as it has access to the API. So for example, if I mentioned like the custom GPT approach before, if you're a developer, you might actually rather be using the assistant APIs and the assistant setup to do this. But as long as you tool that with the API calls to our API, and then you can simply teach it, you can simply give it instructions on how to build out the API queries based on any syntax that you want, it will do so. And I actually think that if you'd, with your example where it's kind of /query and user what and then some references to cells in the model, it would do surprisingly well without you giving it any special instructions on how to read that. But obviously, the more instructions you give it, the more likely it is to be correct. One more here. What are your thoughts on compliance requirements regarding bigger organizations? So they are, so you will absolutely have them. Like if you work in a larger organization, you will probably not be able or at least you won't be allowed to go into the API environment or into our API environment, upload any spreadsheet and start working with it. We have solutions for that. We can set this up locally. We can set this up on a private cloud. So there are ways to deal with that. But it comes down to how deep your requirements are and what the desired security outcomes are. In general, if you're using a cloud service for something already, then this kind of falls into that category. But I also know that there's nervousness around, especially AI, when it comes to these things. So it comes down to setting up the AI environment in the right way. That may or may not be locally hosted, and then our API service can be locally hosted or set up in a similar way. So it comes down to a little bit of a case by case thing. Let's do maybe one more. Right, so here's one. Can we override Excel formulas with hard-coded values if you want to run a scenario analysis or just on input cells that have numerical values only? So the way the API is set up is that it only allows you to apply values to cells that have values in them, which are typically that are assumptions that or inputs into calculations. However, I believe, look at the documentation for it, but I believe that if you know what you're doing, we allow you to override that. So you can actually say, I want to write in this cell and I know what I'm doing. So it will override a calculated value with a value. But there are definitely ways to do this, either in structuring the spreadsheet right or overriding it using the API. There is an important question here, which is, can't I just upload my spreadsheet to ChatGPT? That seems to work. If you attended our chat with Donald Farmer a week ago, you would have heard us talk about this in depth. But the thing is, so ChatGPT and most other LLM environments, chat assistants, are fairly good when it comes to tabular data. So if your spreadsheet is a spreadsheet that has the top row are column headers, and then every row in the spreadsheet holds some data, and what you want to do is some aggregations. Let's say that you have transactions and you want to know the total sales value by product or something like that. ChatGPT and other LLM solutions will do fairly well. They will write code to do that. They would do that on top of a CSV file as well, and they come back with your answers. But as soon as there's a formula anywhere in your spreadsheet, or if the spreadsheet is free form, meaning it doesn't have this columnar structure, it's more like a financial model, which typically has the months going out to the side and some other aspects like the departments or the cost factors going out, going by row, then they will not fare well in finding the values, and they will not even read the formulas. They won't even know the calculations that are in your spreadsheet. So if you want to make use of the spreadsheet models and the spreadsheet modeling that has been done inside of your company, then they won't run in ChatGPT is the short answer there. Yeah, so one more final question here. How does this compare to edge functions, assuming we can code the logic? Just trying to understand any specific use cases where the spreadsheet API works better than edge and vice versa. Now, I think edge functions are examples of, you would write code to run the calculations, and then you could call them from the LLM. If you are a coder and you are coding your functions from scratch, then that is probably a very good way to go. However, if the business side of your company already has spreadsheets that does the pricing calculations for your price quotes, or your risk calculations for your insurance company or something like that, you don't want to be rewriting those in code. That will both be error prone, but it will also mean that you are now bound to, whenever there's a change that the business makes to the spreadsheet, you will have to remake that change somewhere else. So in your code, which makes that whole loop very long. So it's essentially the answer comes down to what's your tool of choice. If you are a coder, you can code edge functions and you can call them, and that's probably the right tool for you. If you are a spreadsheet user, or you are on a team that is working with people, with spreadsheet people, and they are the domain experts, you probably, like, one of the things that our solution allows you to do is that the business users, the ones that know the domain, that know how to do the calculations, they can stay in the environment they know and feel confident in, which is the spreadsheet, and you can stay in the environment you feel comfortable in, which is programming using, or programming a programming language of choice, using an API to bridge the two. And that's that means that our API would be the right tool of choice. So it comes down to the nature of the project. So yeah, I think that concludes the. There are several questions here we haven't touched upon. We will follow up on this via email. So thanks for everyone that attended. Thanks to all of you that attended, and look out for an email with the recording and some additional information coming to your inbox tomorrow. Looking forward to see what you build and what you do with our API solution, and then obviously I and my colleagues will be happy to help you with your project and fill in any questions you might have, and there will be contact information in that email. So that concludes our session today. Thanks so much for your time, and hear from you soon.